when perfection became the enemy. It began with an obsession, quiet at first, then absolute, a belief that every flaw could be eliminated, every variable controlled, every outcome predicted, and for a moment, it seemed like perfection was finally within reach. That moment nearly destroyed everything. This car wasn't built to be revolutionary. It was built to be flawless. The goal wasn't speed or spectacle, but total refinement. A machine so polished, so precise, that nothing could go wrong. Engineers chased silence, smoothness, and uniformity with relentless focus. To understand how perfection turned into a liability, we need to return to an era defined by rising expectations. Consumers demanded reliability without compromise. Regulators demanded zero tolerance. Manufacturers responded by tightening margins on error, on flexibility, on humanity. The project began with extraordinary discipline. Every component was overanalyzed. Every tolerance narrowed. Variability was treated as failure. Systems were layered with safeguards, redundancies, and controls designed to eliminate uncertainty entirely. Early results were impressive. The car performed consistently across environments. Quality metrics soared. Defect rates plummeted. On paper, it was a triumph of modern engineering. But something subtle began to change. The car lost its ability to adapt. By eliminating variability, the engineers had also eliminated resilience. The machine became exquisitely sensitive to conditions outside its assumptions. Minor deviations, unexpected temperatures, unconventional usage, imperfect maintenance produced outsized consequences, not catastrophic failures, but cascading inefficiencies that eroded the very perfection they sought. Inside the lab, warnings appeared quietly. Systems that could no longer compensate. Components that worked only within narrow bands. Software that corrected aggressively instead of forgiving. The car didn't bend. It resisted, and resistance in a complex world carries a cost. The engineers faced a contradiction no one wanted to acknowledge. The closer they moved toward perfection, the further they drifted from reality, because reality is messy. People are inconsistent, conditions change, and machines built without tolerance eventually collide with that truth. The realization came too late. Perfection had stopped being a goal. It had become an enemy, and the car was about to teach that lesson in the most painful way possible. The first signs appeared outside the controlled environment of the lab. Early production units reached real owners, real roads, and real habits that no simulation could fully capture. The cars didn't fail dramatically. They faltered quietly. Sensors drifted out of calibration. Software overcorrected small inconsistencies. Systems designed to operate in perfect harmony began arguing with one another. Owners reported strained behavior, not breakdowns, but friction, hesitation where none was expected, warnings that appeared without clear cause, service visits that ended with updates instead of answers. The car still met every specification, but it no longer felt effortless. Engineers traced the issues back to the same source: intolerance. Components were so finely tuned that natural variation became a threat. Manufacturing deviations once considered acceptable now triggered compensatory logic that escalated minor discrepancies into system-wide responses. Redundancies clashed instead of supporting each other. The machine spent more energy correcting itself than moving forward. Internally, the data was alarming. Warranty claims weren't spiking, but service interactions were. Customer satisfaction slipped not because of failure, but because of fatigue. The car demanded attention. Updates, adjustments, explanations. Perfection had turned ownership into work. Attempts to fix the issues only deepened the problem. Engineers added more controls to manage the side effects of existing controls. Software grew denser. Decision trees branched endlessly. Each fix narrowed tolerance further, compounding fragility instead of resolving it. The system had entered a loop. The more it tried to be perfect, the less forgiving it became. Veteran engineers began voicing concern. They recognized a pattern from other industries. Systems optimized so tightly they collapsed under normal use. But raising that alarm meant challenging the project's core philosophy, admitting that perfection itself was the flaw. Leadership hesitated. Perfection had become the brand's promise. Walking it back felt like retreat. Marketing continued emphasizing refinement and precision, unaware that those words now masked a growing disconnect between expectation and experience. Then came the moment that forced reality into the open, a routine update, intended to smooth behavior across edge cases, introduced a subtle conflict between two control systems. Individually, each behaved correctly. Together, they created oscillation. Nothing failed, but everything felt wrong. The car became unpredictable in ways no test had prepared for. Engineers finally understood what had happened. By removing imperfection, they had removed the buffer that made complexity survivable, and the cost of that realization was about to rise sharply. The consequences unfolded slowly, then all at once. What began as subtle friction grew into systemic instability. Not failures that made headlines, but patterns that eroded confidence. Owners learned to expect updates. Technicians learned to expect ambiguity. Engineers learned that the system no longer behaved the same way twice. The car had become fragile in a new way. In chasing absolute control, the design had lost grace under uncertainty. When conditions drifted outside assumptions, dustier roads, older components, inconsistent charging habits, the systems responded aggressively. Corrections stacked on top of corrections. Instead of absorbing variation, the car amplified it. Internal testing confirmed the fear. Under imperfect conditions, performance degraded non-linearly. Small issues cascaded. Software patches fixed one behavior while destabilizing another. The machine had become a web so tightly woven that pulling one thread distorted the whole. A crisis meeting was called. Veteran engineers argued for a radical shift. Widen tolerances, reduce control layers, reintroduce slack, let the system breathe again. They explained that resilience comes not from eliminating error, but from surviving it, that no complex machine can remain stable without room to adapt. Others resisted. Rolling back precision felt like heresy. Years of work were built on the promise of flawlessness. Admitting the need for imperfection meant admitting the premise was wrong. The debate stalled until the data made the decision unavoidable. Long-term reliability projections dropped sharply, not because parts failed sooner, but because interactions aged unpredictably. The car didn't wear out. It drifted out of balance, and no amount of calibration could restore harmony once it was lost. The leadership finally confronted the truth. They had engineered a machine for a world that did not exist, a world without dust, without aging, without human inconsistency, without entropy. That world never arrives. The solution, when it came, was painful. Engineers began dismantling layers they once celebrated. Control systems were simplified. Software logic was thinned. Redundancy was redesigned to cooperate rather than compete. Tolerances widened intentionally. Performance metrics softened slightly, just enough to restore forgiveness. The car became less perfect, and immediately it became more stable. Test vehicles stopped oscillating. Owners reported calmer behavior. Service visits declined. The machine felt human again, not because it was less advanced, but because it was finally aligned with reality. But the damage to perception lingered. Perfection had promised certainty. What it delivered was fragility, and the lesson carved itself deep into the industry's collective memory. Because when perfection becomes the enemy, survival depends on learning how to let go. The recovery never made headlines. There was no dramatic recall, no public admission that perfection had failed. The changes were introduced quietly, described as refinements, balance adjustments, quality of life updates. To the outside world, the car simply seemed to get better. Inside the company, the shift was far more profound. Engineers rewrote their priorities. Instead of asking how tightly a system could be controlled, they asked how gracefully it could fail. Instead of eliminating variance, they learned to guide it. Imperfection stopped being treated as a defect and became a design tool. The car that emerged from this transition was no longer flawless. It was resilient. Owners noticed the difference immediately. Behavior became predictable again. Updates felt stabilizing instead of disruptive. The machine no longer fought its environment. It cooperated with it. Satisfaction slowly recovered, not because the car dazzled, but because it stopped demanding attention. The industry noticed too. Quietly, philosophies shifted, tolerances widened, redundancy strategies changed. Software teams began designing for degradation instead of ideal states. The obsession with eliminating error softened into a focus on absorbing it. Perfection lost its throne. In its place stood something far more durable: balance. The car that once chased flawlessness became a case study taught behind closed doors, not as a failure, but as a warning, a reminder that control without flexibility becomes brittleness, and precision without empathy becomes instability. It taught engineers a truth they now pass down carefully. Real-world systems don't survive by being perfect. They survive by being forgiving. And in learning to forgive imperfection, the machine finally became what it was always meant to be. Not a monument to control, but partner in an unpredictable world. Sometimes the smallest shift in perspective becomes the beginning of a new future. When